All right, so now that we've went over most of the different types of transcendental functions and taking the derivative of them, we're going to learn integration for them. So first, let's review some of the integrals we've done. So the integral of x squared would give us x cubed divided by that new exponent, 3, plus c. The integral of 1 over x squared I'd rewrite as the integral of x to the power of negative 2 dx, which is equal to, if you add 1 to the exponent, x to the negative 1 divided by negative 1, and when you clean that up, it's negative 1 over x, and then don't forget your plus c. Should have written it here too. Okay, this third one, the integral of x would just give us x squared over 2 plus c. Now let's look at the last one. Your first guess might be to just rewrite it as x to the power of negative 1. When you do that, and you try to use power rule, you'll add 1 to the exponent and get 0. Meaning you have to divide by that exponent, 0. That's undefined, which is why this rule does not apply here. We use the natural log. So let's go back to the definition of our natural log. The natural log of a is equal to the integral from 1 to a of 1 over x dx. We can write that as y equals the natural log of u, giving us the derivative, or y prime, to be 1 over u prime, and you can also write that as 1 over u du dx. If you are more comfortable, did not mean to scribble that. If you are more comfortable with this, that's fine. If you're more comfortable with du dx, that is also okay. Just know what they both mean, and when you see them, make sure you can identify what it is. So the integral of 1 over u du would give us the natural log of u plus c. Now, we can only take the natural log of a positive number, so when you use this rule, you need to put absolute value bars around your function inside the natural log. Okay. Here's an example. Did I skip anything? No. Okay. So before I begin, something super important to mention is that this only applies when your power on the bottom is 1. You can use u substitution to make the power on the bottom 1. So looking back here, we didn't need the natural log there. We needed it right here. The power was 1. So notice, in this first example, the power is 1. So we can apply the rules for natural log.